Okay, so now I'm on address bus 1. Here is my value that is on the register at the moment. And if I switch this to be low, I should see that out here, and I don't. This video is a continuation of the last video, where unfortunately I had to leave on a cliffhanger due to the length of all the footage I had. There was just no way I was going to be able to get all the troubleshooting in. So I complete the troubleshooting. And while I thought I had it working at the end of the last video of all of my recording, turns out I actually still had one additional problem. I found that in this video and got it corrected. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. No, why not? Now my problem could be in my test harness, my output LEDs, or my problem could be up here in my wiring. And if my problem is up in my wiring, that's going to be a really difficult thing for me to sort out. There we go. I've zoomed out to allow you to see things a little bit better. Let me raise the back end of this again to eliminate some of that glare. Okay, now the question then becomes, am I getting power all the way through my build? Let's start with that. Since it wouldn't power on, I have a suspicion. So I have a ground lug. I'm going to move down here so that I can set ground right there. Barely see it on the bottom of the screen. And then I'm going to grab a wire up here. Okay. And 4.96 volts. So I'm getting power all the way up there, so that's a good thing. Can I measure it there? That's not low. 2.3 volts is not a low signal. So the question is what's here? 2.3 volts. So ground versus ground. Okay, that's interesting. 6 volts. So my ground reference to a floating pin is showing 6.6 volts. And that shouldn't happen. So I've got something cross-wired somewhere. It's 2 volts there. Now how can it be 2 volts there when the orange line from 19 to 1 is cross-connected? Still 2 volts. I'm going to have to get my head in the way here so I can see. Okay, let's measure this because all 4 of these are cross-connected. Maybe I've got a bad IC. That's 2 volts. All right, let's start with pulling that out, pulling this out. And that then should eliminate the cross connections. So if I want to output, that should be, why is that 7 volts? Nothing. Why is that pin outputting 7 volts? That pin's got 2 volts. This is pin 1. This is pin 19, which has 5 volts on it. Let's make sure I'm not touching that lead of the capacitor. 6.8 volts. They're not getting hot. Now what if I took power and dropped power up here? That is very dim. All right. Well, I wasn't going to do this now, but let's see if it helps. These are more of the 47 microfarad capacitors. And let's see here. That is the minus side, so this would be the plus side. Okay, so that doesn't work. Grab some more wires here. Let me see if I can drag power and ground down, because power and ground is being chained all the way through these, and I've reused some wires to do this. Let's see here, plug power in there, and I'll drag it up to here. Then ground here, and I'll drag it up to, whoops, so let's drag it up to here and see if that improves it. It does not. Everything is quite dim still. Let's do this. Now that helped. And that fixed it. So I have a problem. More than likely this is shorted. And I don't know if you can see that, but I lost the lead on that. So that is actually where my problem was. I was barely getting a connection there. Let's see if we can do this without making a mess. Perfect. All right. Now, see if I can put these back together. See if that actually, well, let's test a couple of things here. I should be able to hook here and go to ground and get output, and I am. So that's a good sign. So let's hook the jumpers back up. So there's pin 19. Forgive me for moving here. Okay, pin 19 to pin 19. And then pin 1 to pin 1. it is not going back in. Okay, and then I need my jumper to connect 19 back to 1, so they're driven by the same signal, and everything is outputting properly. Let's clock that. That worked well. So that's good. And I'm seeing now a problem with my power supervisor. So that's what this is indicating. So I do have a power problem now. I'm going to replace all these lines. And there, the power problem went away. So that's good. I'm going to replace all these power lines that I had scavenged off of a previous build because of things like this. It looks like the solid core wire was stressed, and I probably cut into it a little bit on my prior build, so I'm going to have to cut all the ends off of each of these and restrip back in order to get a good connection, which is fine. I can do that. Okay. So that's good. So now let's turn this off so I'm no longer outputting. I will jump over here to these line drivers and then change the output so I'm outputting the data. And again, that works just fine. So that's good. Turn that back off again. Let's try. I need to see where I'm lining up here. Let's try this one. And as I'm pushing down on this, I'm actually bending the breadboards, which is not probably a good thing. So now I've got a light lit, and I shouldn't have a light lit. So why do I have a light lit? Because I got it lined up wrong. That's why I have a light lit. And again, output, and that looks good. Move it over one more. I apologize, I'm going to lay these flat. And then I will take this one low. And once again, I get good output. So that's so far so good. Now, this one's going to be fun because this one I can connect up once and test both outputs because they're all joined here. If I take this output low, I've got something funny going on here. I did not check this against the output prior. So, looks like I've got a bit swapped somewhere along the lines here. If I take that back high and take this one low, allowing it to output, I should have the least significant byte, and I'm covering up the LEDs that are not used. I got my wire in the way. So if I cover up the least significant, look at the least significant byte here, that's accurate. And then if I look at the most significant byte, the byte swap, and I've got a pin that is out of alignment here. So 0100. That tells me that I've got something wired incorrectly up here. So let's see here. Yes, I do. I have all of these off by 1. So let's pull power and move these over by 1. All right, let's try that again. Okay. So now I am not getting any output. Why am I not getting any output? I did not move the last one over. Okay, so no output. So this is correct. This one's not being output. So the most significant, which is what I just moved over, and I'm looking to see if pin 1 is wired correctly. It looks like it is. So I should, let's see here. Let's try taking that and going straight to ground with it. No. Well, wait a minute. It's not that one that should be outputting. It's this one that should be outputting. 19 to 19. So let's trace this back here. That works. I'm bloody brilliant, Adam. Okay. And that is aligned properly. Okay, so let's go back and test now this one again. And I do have a bit that's off. I have a bit that's swapped somewhere along the lines. So the output is coming off of here. Is it an input? And get my logic probe. Okay, so for me to have wired this up correctly, 100% without any errors would have been absolutely remarkable. I did not expect that to have taken place. All right, so I'm checking let's do this one. Because I'm outputting the normal. So let's see here. 0, 1, 0, 0, 1. So this line here is high for some reason. It's 0, 1, 0, 0, 1, 0. Okay, so that's correct there. 0, 1, 0, 0, 1, 0, 1, 1. That's correct there. So my crossover happens in these wires here. So 1, 0, 1, 0, 1, 0, 1, 1. Does my crossover happen here? Zero, 1. 0.00. So that's accurate coming in here. It's inaccurate coming out here. Yep. I crossed over 2 bits on this ribbon cable. So that's going to be fun because these are not easy to pull out. I don't know if you can see this here, but I managed to get it crossed right there. Let's turn this off. Now, what can I use for a lever to lift this up? Slide this over. Let's use my probe. Let's get a nice fat, nice pointy piece on it. Yep, that bent that up. That's not good. Push those down again so they will make contact. I might have ruined that. And if I did, I'll be grabbing a new one. So let's put these back in the correct order. Okay, that's good. Let's try the one that's probably going to fail first. I think I can make that work. All right, let's put this back in. I will put this end in this side. That way it doesn't have to move very frequently. And then I'll put this end up here. Apply power again. Tick the clock. And that is accurate. So that was fun. I hate it when things don't work right the first time, but it was good to see some troubleshooting. Okay, for cleanup, I first start with the power and ground on the right side of the board. I try to reuse the existing lines, but those don't end up working out so well. I have to go over the chips, and they just were overall too short by the time I cut them down. So I got frustrated, threw them away, and cut fresh wires for those. Probably for the better anyway. Then I go after the power rail decoupling capacitors. These are the 47 microfarad capacitors. I cut those leads to length and get them stuck into the other side of the breadboard. This is where power is generally going to be coming from, at least for now. So I want to have it as close as possible to the power inputs, just to improve things. And then I get the timer hooked back up and get power hooked back up and give a quick test. Okay, with all the known issues worked out, the last order of business here is to make sure that I prove to myself that everything really is working the way I expect it to. So I'm going to run through each of the buses and ensure that each light lights up in turn and that I actually get everything on or off as the case may be. So if I clock it now with everything here set to high, I now have all of the bits here set in the register. If I turn the output on up here, all of the bits turn on. If I turn one off and clock it, off here, off here. And I will continue through this. It's a bit 3, bit 4, starting numbering at 0, bit 5, bit 6, and bit 7, and that is the low order byte. 8, 9, 10, 11, 12, 13, 14, and 15. All right, perfect. So now I disable this. I move the outputs over to the next line driver. Start outputting that. Again, it's all off, and I just continue on through the list of outputs. While I'm doing this, I'll probably fast forward unless I come up to a problem. While I'm iterating through all this testing, if you have any questions or comments related to the videos, leave them in the comments section below. I know I'm just getting started out, and your feedback is important to me. Okay, that bit is swapped with that bit. And so now I need to try to figure out where. It wouldn't be there. It might be up here. And it's going to be this bit here. And that bit there. Okay, so back to testing. Okay, that's correct. That's correct. That's correct. That's correct. And that's correct. Okay. Well, that at least proves to me that this is working the way I need it to. So one additional little fix in here. A couple of bits were swapped. Easy fix. So left to do with the register is to add the increment decrement control and make sure that I have that capability to do the increments and decrements. And then I have the register load and assert control circuitry that I need to add in as well. And finally, the KiCad design in order to get a printed circuit board made. And again, I have a request. If you would like to see that, if you would like me to record it and figure out a way to present that, I'm more than happy to do that. I'm love to hear some advice on that as well. Finally, I still have a couple of things left to do on the clock. These are smaller tasks, and so I will work those in as time permits. We'll see you again soon.